Ladies and gentlemen, imagine for a moment that the world we inhabit is not the concrete reality we have always believed it to be. Instead, it is a virtual reality, meticulously crafted by an advanced computational system beyond our comprehension. While this notion may sound like the stuff of science fiction, an increasing body of theories and evidence compels us to consider the unsettling possibility that our existence is part of an intricate simulation. Let us delve into the roots of this profound hypothesis, starting with the simulation theory put forth by philosopher Nick Bostrom. Bostrom posits that if a civilization becomes technologically advanced enough to create perfect simulations of reality, it is statistically more likely that we are living in one of these simulations rather than in a base reality. As we witness the rapid advancement of quantum computing and artificial intelligence, the capacity to simulate increasingly complex systems becomes less of a theoretical question and more of an inevitability. If we project the trajectory of our technological progress, the ability to replicate a universe indistinguishable from reality is within reach for a sufficiently advanced society. Now, let us turn to the peculiarities of our physical universe, peculiarities that may hint at its artificial nature. Quantum mechanics reveals that at the most fundamental level, reality behaves less like a continuous fabric and more like discrete data points, akin to the pixels of a digital image. For example, particles such as photons exist in superposition, occupying multiple states simultaneously until observed. This behavior mirrors how a computer renders a virtual environment only when the user interacts with it. Could it be that the universe operates on a similar principle, conserving computational resources by rendering reality only as needed? Consider also the mysteries of dark matter and dark energy. These enigmatic forces comprise the majority of the universe's mass energy content, yet remain undetectable and poorly understood. If we view the universe as a simulation, these could represent programming elements or computational constraints. Perhaps dark matter is a form of code that sustains the structure of the cosmos, while dark energy drives its expansion in ways we cannot yet decode. Even the black holes that punctuate our universe might align with the simulation hypothesis. These gravitational anomalies, where time and space collapse, could be glitches or boundaries within the program, places where the computational system encounters limits in its processing power. Alternatively, they could serve as repositories of data, akin to the memory storage of a colossal cosmic computer. Some theorists have even speculated that black holes might be the gateways through which simulations are linked, connecting different instances of virtual realities. The rapid evolution of virtual reality technology lends further credence to this theory. Today, our VR environments are increasingly immersive, blurring the lines between digital and physical experiences. With each advancement, it becomes easier to envision a future where simulations rival or even surpass reality in fidelity. If we can already create rudimentary virtual worlds, what prevents an advanced civilization from constructing a reality so flawless that its inhabitants remain unaware of their simulated existence? Furthermore, consider how augmented reality and neural interfaces, such as brain-machine connections, could soon enable us to manipulate our perceptions at will. The line between what is real and what is constructed is becoming increasingly blurred. Now let us explore the subtleties of human experience, moments that might hint at the artificial nature of our reality. Have you ever felt a sudden, inexplicable shift in time? Days that pass in an instant or moments that stretch endlessly? Or perhaps you have noticed coincidences so uncanny they seem orchestrated. These phenomena might be remnants of a simulation's algorithmic structure, where probabilities are subtly adjusted to maintain coherence within the system. Déjà vu, a sensation many experience, might be interpreted as a momentary overlap in the system's processing, a glitch in the matrix, if you will. Moreover, consider the human brain itself, a biological machine of staggering complexity. Neuroscience has yet to fully understand the mechanisms of consciousness. What if consciousness, rather than arising naturally, is an emergent property of the simulation's programming? In this context, our thoughts, dreams, and emotions could be intricate lines of code, creating the illusion of individuality and free will. Studies on artificial intelligence have shown that machines can emulate decision-making processes and even exhibit rudimentary forms of creativity. If AI can mimic aspects of human cognition, who is to say our own consciousness is not similarly synthesized? Let us also not forget the argument of computational capacity. If an advanced civilization has the computational power to simulate not just one, but billions or even trillions of universes, the odds of living in the original, base reality diminish. This raises profound questions about the architects of our existence. Who or what are they? Are they benevolent creators, mere experimenters, or indifferent programmers? And to what purpose do they maintain this simulation? Are we subjects in an elaborate study, participants in a cosmic game, or creations of sheer curiosity? Could our suffering, joys, and triumphs hold meaning beyond the confines of this program? Or are they simply artifacts of a system designed to simulate complexity? The implications of this hypothesis are staggering. If our reality is simulated, it fundamentally redefines our understanding of existence, morality, and purpose. The very fabric of our experiences, love, pain, achievement, and loss, would take on new dimensions of meaning. It might also challenge the way we approach scientific discovery, as the rules governing our universe could be artificially imposed rather than intrinsic. What if the speed of light, the laws of thermodynamics, and even the flow of time are parameters set by the creators of the simulation? The simulation hypothesis even echoes themes from ancient philosophies and religions. Many spiritual traditions propose that the material world is an illusion, a transient facade masking a deeper truth. Could these ancient insights have been intuitive glimpses into the true nature of our reality? If so, the simulation hypothesis might bridge the gap between science and spirituality, offering a unified perspective on existence. The concept of Maya in Hindu philosophy, which describes the illusory nature of the world, resonates strongly with the notion that our reality could be a construct. In considering this possibility, we must remain cautious yet open-minded. The evidence is circumstantial, but the questions it raises are vital. As technology advances and our understanding deepens, we may find ourselves on the brink of confirming or refuting this hypothesis. Until then, the pursuit of truth must remain a cornerstone of human endeavor. Imagine if the breakthroughs in quantum computing or neuroscience finally provided empirical proof of the simulation's existence. How would humanity react? Would we seek to escape the simulation or embrace our role within it? What lies beyond the veil of our perceived reality? Is it a higher plane of existence, a vast computational network, or something altogether incomprehensible? These are the mysteries that drive our quest for knowledge. In seeking answers, we affirm our humanity, whether as free agents in a genuine cosmos or as conscious beings within a grand simulation. Perhaps the ultimate purpose of this simulation, if it exists, is to explore these very questions, to challenge the boundaries of what we perceive as possible and to seek meaning in the face of the unknown. Thank you.